Welcome to Brain Vision.
Okay, so for the first question, we can apply the energy balance equation. So we have E dot in is equal to E dot out. If we expand it, we have Q dot in plus M dot H1 is equal to M dot H2 plus W dot out. If we do some arrangement here, we have Q dot in is equal to M dot times H2 minus H1 plus W dot out. Q dot in here is the rate of heat transfer to the air, and M dot here is the mass flow rate for the air, which is the mass flow rate of the air that the fans need to deliver, okay? And H1 here is the initial enthalpy for the cooling air, and H2 here is the final enthalpy for the cooling air. W dot out here is the power output by the fan mounted at the inlets, okay? So now we know H2 minus H1 is equal to Cp times T2 minus T1. Cp is the specific heat of the air at a constant pressure. And we know T2, which is the final temperature for the air, and T1 is the initial temperature for the air. If we plug in back to the equation, we have Q dot in is equal to M dot times Cp times T2 minus T1 plus W dot out, which is equal to M dot times Cp times delta T plus W dot out, because the changing temperature is equal to the final temperature minus the initial temperature. So therefore, we have M dot, which is the mass flow rate of the air, is equal to Q dot in minus W dot over Cp times delta T. So we know the Q dot in, which is the rate of heat transfer to the air, should be equal to A times 10 watts, which is 80 watts, since each PCB is dissipating 10 watts power, and there are 8 of them. Okay, so we have 8 times 10. And we know the specific heat for the air is about 1005 joule per kilogram times degree Celsius. And we know the changing temperature is given as 10 degrees Celsius. And the power output by the fan mounted at the inlets is about 25 watts. Since it's power output, so we put a negative sign here. So we have negative 25 watts. So now let's plug in back to the equation to determine the mass flow rate for the air, which is equal to 80 watts minus negative 25 watts. And then over Cp delta T, which is 1005 joule per kilogram times degrees Celsius, and then multiplied by 10 degrees Celsius. And this will give us the mass flow rate is about 0.0104 kilogram per second. So now for the next question, let's try to determine the temperature rise of air due to the heat generated by the fan and its motors. So first, we know the W dot out absolute value here can be equal to M dot times Cp times delta T2. So we know M dot is the airflow rate, and Cp is the specific heat for the air, and delta T2 is the temperature change we need to define for this question. So if we do some arrangement here, we have delta T2 is equal to W dot out absolute value over M dot Cp. So we know the absolute value for the W dot out is 25 watts. We know the mass flow rate is 0.0104 kilogram per second. And we know the specific heat is 1005 joule per kilogram times degrees Celsius. So now let's plug in back to the equation. We'll have the temperature rise due to the power outputs, which is supplied by the fan mounting at the inlets, is about 25 watts over 0.0104 kilogram per second, and then times 1005 joule per kilogram times degrees Celsius. And this will give us the changing temperature, or the temperature rise due to the fan mounted at the inlets, is about 2.4 degrees Celsius. So now let's compare this temperature rise with the maximum temperature rise, which is the 10 degrees Celsius. So we have delta T2 over delta T, which is 2.4 degrees Celsius over 10 degrees Celsius. And this will give us the fraction is about 0.24. And this is the answer for this question.